Welcome to episode 25. We have here Challenger Base on its way to the moon, on a journey of scientific discovery and analysis of all the moon's biomes and anomalies. We will probe the secrets of the moon and find its secrets. Yeah. We enjoy a lovely eclipse of carbon as we enter the sphere of influence, one that carries over to the moon. Look at that there, just a black ball. Very foreboding there, kind of like a black hole. But as we approach the moon, it exits the shadow of carbon, and it is almost as if we cast a light on its surface. As we approach, we will illuminate the secrets of the moon. We will shine a light in the dark corners and find every single thing that it has to hide. But first, we have to put ourselves into orbit. We have the maneuver there to do just that, and just raising our periapsis so we don't actually collide with the moon, because that would be a rather embarrassing way for this mission to go. They have been in space for all of 1 day, and I don't want to lose this. So it was very expensive. This took like half of the funds that I had. So coming in close to our periapsis, and we're just going to bird retrograde, and that will put us into an orbit, and from there we can begin to pick our landing site. I'm going to try to land on the near side of carbon, at least for now, because then it's just easier that way. We'll have full communications, we'll be able to see it, and that's also the only side that's illuminated. So we get into orbit, and then we pick out a landing site. I'm going to go for this crater. I forget what it's called. We'll find out when we land there. But coming in now, there's tons of RCS on this. I've also put a bunch of reaction wheels, and the engines on the base itself have pretty good gimbaling, but the RCS is there because I want this thing to be as nimble and maneuverable as possible. This is a very, very heavy vehicle, and I want to be able to maneuver it quickly in case things go wrong. And you can see there on the Kerbal Engineer, this thing weighs like 10,000 kilograms. It's pretty heavy. So we're burning away the rest of the fuel in this stage. And we're going to have, about 500 meters per second, 560 meters per second in the actual base itself, which is not enough to get into orbit, but enough to get pretty good range around the surface of carbon. And in this case, it will be enough for us to slow our descent and land. This whole area is pretty flat. I don't want to land in one of these little craters because then it would end up not going very well. Those ore tanks on the side, those little black cylinders that the radiators are attached to, those are the ore tanks, and they're empty right now. But as they fill with ore, this thing will get more and more top heavy, and that could be a risk if I land on a slope, because I don't want this to topple over. If that happened, I don't think I could get it back up. So we're just slowly descending. We have a lot of delta V here, so taking it nice and gentle and just killing off that speed. We are going to come down on a bit of a slope, but it's nothing too crazy. The RCS and the reaction wheels and the overall wide base of this thing should be well enough equipped to handle it. And a nice and slow landing, one that bounces. Now, to eliminate this, I roll the entire thing until our long axis of our base is oriented along the slope. That way we will be as stable as possible. Extending all the ladders, and we can now begin operations. Irlas Kerman is the scientist on board this vessel. As she takes the EVA science pack, climbs down the ladder, and goes on to do flag duty. We plant the flag to commemorate our landing site. Challenger Base landed in the Northwest Crater. Challenger Base reporting for duty. Yes, the Northwest Crater, that is where we are, and that is the first stop on our science tour across the moon. We play a little golf, and we get a bunch of science from it. And then, once that happens, we can climb back up the ladder, go in the lab, and be able to start processing the data. Now, the other thing I have, Jarek is going to step out. She is our engineer, so she will help us with our operations on the surface. But we have stored in a equipment bay there on the side some stuff to put some little seismic probes around the surface of the moon. So we deploy this ground anchor, and then we put a battery on top of it. And then I have this probe core, a single solar panel that I take care to align along the axis of the sun, seismic accelerometer, and an antenna. And this should be a self-sufficient, like, seismic probe that's just going to sit here. And I have enough for 2 more of these. So in a few other places, I'm going to put some. I'll probably put one on the far side. And due to, I guess, an unintentional feature of Interstellar, I can detect the impact of something that happened before the seismometer was deployed on the body. Just admiring the inside of the lab there. This lab is from the Interstellar pack, but it uses the same interior as the stock lab. And we start processing all of the surface science that Erlas performed. Then with all of these experiments, the find dust has intermixed with the samples. We process that. The sensor has detected a minor quake. We process that. The magnetometer from the surface, something the interstellar magnetometer does, and all the other experiments. And we store those in the lab, and we'll start processing the data. And the way that'll work, I guess, is all of the data is removed from those modules, and we can also level up the crew with the lab and clean the experiments. But it'll just sit there and churn and increase the science gains over multiple days, and we can transmit it back. In the meantime, we start our ISRU, so we start deploying the drills and mining the ore. Admire the view from inside here. And yeah, we're just gonna kind of sit here like this for a while. Now, after some time, we admire the view, of course, a lunar sunset. There's a ton of electric charge on this thing, 16,000 units. And those drills and all the life support are draining some of that, but we have enough batteries to last a lunar night, which is only about a couple of days long. But we have enough for about a week of electric charge for life support if we shut down all the other systems. Now, these drills are operating dismally. And that is a problem we will have to fix in the future because our Eve window is here and we are launching our crew, Agadan, our test pilot, who is now getting a chance to fly in space, as well as 2 other Kerbals, Stelfrid and Sigmund. These 3 will be the ones who break all sorts of records. They will be the first Kerbals to leave the clutches of Kerbin's gravity and visit another planet. They will spend probably the longest amount of time in space, barring, of course, the crew on the Skylab, who I have completely forgotten about until this point. So we're just going to rendezvous with the rest of the spacecraft. Now, if you remember in the last episode, I mentioned that this section is going to go kind of in the middle of the spacecraft. So we're going to have to do a little bit of disassembly and reassembly once we actually arrive at the target. But first we have to get into orbit. And we're not too far behind. We're only about 70 kilometers behind. Or about 90, actually. Or 110, I guess. Then we circularize, and we're in a lower orbit. So we'll catch up over the course of several orbits, perform our rendezvous and all of that. And we get a pretty close one right away. But we have to circularize. And, of course, it gets messed up. Now, I do have to deploy all of these antenna and solar panels. There's a docking port on the back and the front there, as you can see. There's some life support, and most importantly, the heat shield, which will protect them on their return to Kerbin in, well, a while once they complete their mission and come home. So now we're here. We have to separate this. So we undock that, give it a nice kick backwards, and then we do some magic with the camera angles to target that docking port. And then we orient ourselves, line it up with that one, come in to chase it down, and then dock with it. And we just line everything up with the indicators on the docking alignment there until we arrive and dock. And now, there's not a lot of RCS power on this, and for some reason we're drifting very quickly sideways. But this one has a lot of RCS power. It's meant for that. So what we can do is basically just chase down the rest of the spacecraft with the lab section. And we can just line ourselves up, and very gently we can dock. So this is the spacecraft. We're going to put some struts on here so that it does not wobble around. But we can admire the interior in the meantime. So they're all in this capsule here, the return stage. But we can bring them inside the actual vessel proper. Admire the view out of the windows in this crew can. Carbon visible out of both ones. And then we go up into the lab, of course. Admire the inside. And then we can visit the lander in here. So this will be, they will take this down to Gilly. And compared to the rest of it, it is the only one that will experience negative G's when they accelerate, which is a little unfortunate, but, you know, it's not that big of a problem. So we transfer the crew around. And yeah, so now Stealthrid has to keep all these names straight. I almost called her Jarek there. Jarek's on the moon. Stealthrid is going to put struts between all of these docking ports because as we maneuver this, all of these docking ports are weak, kind of narrow spots, and we need to be able to turn this thing without it flopping around like a wet noodle. So just flying around between all of these different joints here, figuring out the best angles for everything, and putting all the struts between these joints here, making sure that everything is nice and reinforced. Now, of course, as is common knowledge with Kerbal anatomy, they have extremely long arms. The engineers specifically are able to train their arms to extend even farther than normal, which is how she's able to span this probably like 10-meter gap just by holding onto the ladder there. Of course, she's manipulating it probably with telekinesis, honestly, because she's holding on to it. Engineers have some bizarre powers. But we get her back inside, and we prepare for our departure burn. Now, this is with that nuclear engine from Interstellar, and there's only one. It doesn't have great thrust, but it has terrific efficiency. So we'll have to complete this burn in several parts. I'm going with the delta V indicator given by Flight Engineer because that is actually accurate. 7 kilometers per second, compared to the 800 meters per second claimed by the delta V readout there. But we can admire the view. So this is a nuclear thermal engine. And these are a mostly conceptual technology in the real world. Basically, the way it works is you have some kind of a nuclear reactor, like a chunk of fissile material. In this case, it is enriched uranium. And as you know, radioactive things tend to be very good sources of heat. And reactors can get very hot. Actually, it's a problem to make them not get too hot, because if they get too hot, then they can melt through your shielding and have all sorts of problems, and you will have a very bad day if that happens. But what you can do is, instead of combusting fuels, which ends up, because of chemical inefficiencies, most engines are either fuel-rich or oxidizer-rich, simply because if you use the optimum chemical ratio, then your engine will just melt. So you want to basically pass your fuel over this hot reactor core and give the heat into it, and it expands into a hot, fast-moving gas, and you use that expansion to produce thrust. Now, because it's not nearly as hot as a combustion reaction, you don't get as much thrust because the exhaust is not moving all that fast, and it's not very heavy because it's typically hydrogen. We enjoy a lovely solar eclipse through there. But because you use a light propellant like hydrogen, it can get going very fast, and that gives you great specific impulse. So they don't have terrific thrust to weight performance, but they're very high efficiency engines. Now we are catching up with the moon's shadow here, and we enjoy a second solar eclipse as we pass directly over it. Look at that. Surely they're giving a live feed to the crew down, to the Kerbals down below on Kerbin, as they watch this solar eclipse. One every single month, and a lunar eclipse, because of course the moon is not on an inclined orbit. But the moon is catching up with us now, and we get a third solar eclipse. Truly a wonder of nature. Falling back to Kerbin, and we're now going fast enough that this burn should take us out of the sphere of influence entirely. This will be our last close pass to the planet of Kerbin. They can enjoy one last view of its green and blue and yellow vistas before going off into the infinite black void beyond. Lighting up the engines, we're now past 3 kilometers per second, and we'll have an encounter with the moon actually if we keep going like this. But the moon is not our concern, that is for the crew of Challenger Base. No, our concerns lie much farther along. They are with the purple planet of Eve that has been visited only once before, and we get our closest approach, finishing up our burn, and we get that down 1.1 million kilometers, 500,000. Will we get an encounter? We will not get an encounter. We'll plot maneuvers and course corrections to bring us close to the planet of Eve, but for now we can enjoy the view of Kerbin, the fragile blue marble that it is, falling away behind us. And we are now the first Kerbals to cross the sphere of influence of Kerbin. And look at that, all 3 of them are enjoying this. So we're gonna do the first interplanetary spacewalk. So we can... well, first we have to transfer the crew, of course, into the lab so that we can do the research of the solar science that we will collect. Sigmund, our scientist, is going to step out. You feel small right now, you sure you. Hope you know where you're going. And the stock message for that one. Yes, we do know where we are going. We're going in to Eve. Gaze into space. All of these different messages that are going by very quickly. Materials Bay. Rocks show little signs of change. The goo does something. You scan for gamma rays. And all of these things. Most of these we've seen before. We're just getting the rest of the returns from these because, well, we haven't been able to do crewed missions here, so we haven't been able to get full returns. But with a fully functioning lab suite, we should be able to get even more science out of these. And they'll process that data on their journey in. Until we arrive at Eve, it'll keep them busy. But that will be in several hundred days. And we have plenty of other things to do in the meantime. So we can just wait and watch as Kerbin falls away. Now back on the moon. Due to the laws of thermodynamics, and me not having enough radiators on this, our drills are not performing well. So we should be getting much more ore than this. The ore concentrations around the moon are very uneven. But in the place that we're at, there should be about like 2% ore in the surface, which is plenty. I mean, there's concentrations over there, but we should have enough. We should be getting more ore than we are. And indeed, when we look at the drill layouts, it helpfully tells us in a moment. Once I stop the ISRU. Yeah, it helpfully tells us we're getting basically 0 ore per second. So I have to add some radiators to this thing, which is what this little vehicle is for. Launching off the launch pad there. And I'm going to cut out most of the launch sequence because we've really just seen all of this before. Now coming up out of the atmosphere, there go the fairings. So this is basically just going to deliver a bunch of radiators, and we'll strap them on the sides so that Jarek can EVA and do some space construction and rocket surgery and put the radiators where they need to be to dissipate the heat away. Of course, I'm not sure exactly how a drill would operate on the laws of thermodynamics. I don't think it's... Generally, a drill is more mechanical rather than thermal. Although I guess there are material limits, and you have maximum operating temperatures of mechanical components and things like that. What would make sense is the ISRU having a thermal efficiency. Of course, this is... you usually see thermal efficiency in terms of like power analysis for like a power cycle, where when you're trying to use... it's basically a measure of how much energy you're extracting from the flow of heat from one body that is hotter into another body that is colder. That's just some basic thermodynamics for you there. And it's basically the larger your thermal gradient, the bigger difference of temperature you have between those two reservoirs, then the greater power you can do, the more work you can extract, and the higher your thermal efficiency will be. So we're just kind of piloting our way in close. We want to land right next to the base so that we will have to walk a minimal distance to do all of the rocket surgery, all the operations that we're going to do. So getting ourselves in, I'm just going with the red marker there because that's honestly what's easiest. Adjusting and trimming ourselves down until we'll get pretty close. We should be landing within a few hundred meters of it, which is going to be good enough. I'd like to be closer ideally, but I'll just take what we can get. There. That looks pretty close. Maybe 100 meters away from it? Maybe even less. I think we can get 50 meters. So just coming in now. Gonna kill our speed at the last second. This is a little bit far. So we can adjust that in the future. Or we could adjust it now, honestly. I'm just gonna let myself drift along the surface. We still have plenty of fuel in this thing. Those 4 spider engines have good efficiency. Not as good as some other engines, but enough for something of this size. And we touch down about 40 meters away. So now we can EVA, and we can... Well, first we have to stop the drills, of course, because, you know, safety. Although safety is not usually concerned with the Kerbals, it's just a nice step to take. So we can transfer. We have these radiator panels. We can stick those on there. This was honestly very tedious. I'm going to cut most of it out. But I decided that's not far enough, and I actually want to get closer. Figuring out the best way, what keys I have to press to point in the right direction. Turns out to be quite tricky. But it's this way. So we go this way, loft ourselves up, and just kind of slowly and awkwardly drift our way across the surface until we get a few meters closer. However close this is, this seems good. Good enough for me. So now we're going to finish the radiators. And there's no useful equipment on this probe other than that, but I do have a plan for it. So now I'm just gluing the radiators to the side, and I should be able to attach them to the places I want to from the ladder. So Jarek climbs on up, and we can just put the radiators on the ISRU and on around the drills, because those are the hottest parts. Those are the ones that need the greatest thermal gradient. And board, we can now, let's see, we can now deploy and activate all of these radiators. So cooling is on for all of these. They are now radiating off our heat in the infrared. And yeah, there goes our thermal efficiency, 100%. That's usually not a number you see in actual systems, but you know what? We'll take it here. And we are now getting much more ore much quickly, and we finished processing all of the ore into fuel. Filled up our tanks. Look at that. 540 meters per second. So now this I'm just going to use as an impactor. More science. We can fly this on over out of the crater because I want to get it. I'm not sure if... I can't tell if you get science from where the impactor is or where your seismometer is. Although I think location is a factor. Only one way to find out is by trying things out. No one tell me about the wiki. And now we can pick out our next location after we get the seismic data from that. Although actually, I'm going to take some copies of all the data so that once we transmit everything from the lab, we have some more science returns. I'm not sure if this is actually going to do anything, just getting as much science as we can. We can always come back to the northwest crater if it turns out to... If I turn out to have missed out on some science points. So now we collect all of these and, of course, stumble over everything. It's a miracle she's not torn her suit or cracked her visor at this point. I'm sure the Apollo astronauts didn't have to worry about things like this. They just had to walk around and put things in places and collect rocks and go do things like that. None of this flying around into crevices and tumbling everywhere. Another copy of the EVA science. Do a nice little spin. Deposit all the science in the cockpit. We can get some science from space above this biome as well. And yeah, transmit the ones we can transmit. Keep everything else. And now we can pick out our next landing site. Transfer Irlas back into the lab so that we can continue the research. So there is an anomaly in this crater that's just to the southeast of us. Right there, that question mark on the left window there. And we're going to fly to that and see what it's all about. So we take off and point in that direction, but we are nearing the end of this episode. So it's time for me to say we'll see what happens in the future. Until next time.